Alright, let's kind of pick up where we left off yesterday. Yesterday we did a little multiplying exponents and we did a little power to a power. Today I just want to kind of give you just a brief recap real quick of what we talked about. Remember, if I have something like this, x to the fifth power times x to the third power, well, remember, I'm multiplying the same bases. Your graphic organizer says to add your exponents, so that's going to give you x to the eighth power. Okay, you guys are doing really, excuse me, well with that. But I want to look at something that we talked about in class today. What if I have something like, well, let's talk about this first. What if I have 6 to the second times 6 to the fourth? Okay, so if I look at that same concept, I have the same bases. My bases are 6, so I'm going to keep my base. I'm going to add my exponents. Okay, so I have 6 to the sixth power, and I can find that number by taking my calculator and raising 6 to the sixth power gives me an answer of 46,656. Now remember, all it's going to do is going to ask you, if your answer is in exponential notation, you want to leave it like this. If it asks you to evaluate or solve it out, that's the answer I'm looking for there. Okay. Now, this is what we were talking about in class today. Some of you were kind of getting a little confused. If I have something like 5 to the second times 3 to the third, okay? So, I'll tell you what, let's do this. Let's back up. Let's use numbers. Let's use some variables first. What if I have x to the fourth times y to the fifth? Well, if I look up here, this is an x, this is a y. They're two different bases. So I can't do anything with those, so my answer is just simply x to the fourth, y to the fifth. You can't combine two bases that are different. Okay, so remember, we've been keeping the base. So let's try a number. Let's see what would happen with a number. What if I did something like 5 to the first power times, let's say 2 to the third power? Okay, so if you look, the bases are different, so I can't multiply 5 times 2. So what I've got to do is I've got to work the left side as a part of a problem. So 5 to the first power is just 5. And then 2 to the third power gives me 8. Remember, 2 to the third power is 2 times 2 times 2. Okay, so that gives me 8. So 5 times 8 is 40. So the difference here is these bases cannot be multiplied together. All right. Well, let's look at something that may be a little bit different. What if I had 6 to the fourth power times, let's just say, again, let's try one more. Let's just try 4 to the second power. Again, totally different bases. 6 and 4 are bases that are not alike, so I can't do this. So 6 to the fourth power will give me a number of 1,296, big number here, times 16, because 4 times 2, I'm sorry, 4 to the second power is 4 times 4. So then I've got to multiply that times 16 would give me 20,736. So you'll see these numbers, excuse me, 736. So these numbers are going to be pretty big numbers based off the fact that I cannot combine these two. Okay, so that's the one thing I'm really concerned about with today. We were trying to multiply those numbers and we really shouldn't be doing that. Okay. All right, let's look at what do we got. Let me try one of these. What if I have something like this? Let's just remember, just again, we're just refreshing. What if I had something like x to the second, y raised to the fifth power? Well, if I look in here, I have a ghost. Remember, we call it a ghost, but remember, every exponent, every variable has an exponent. So we're going to draw two rainbows. So that gives me x to the second, y to the fifth. Final answer, because I don't know what the value of x is, I don't know what the value of y is. Okay, so just keep working those. Let's try a little bit of a combination. What if I have something like 2m d to the third raised to the fourth power times md raised to the third power? Well, first off, let's check. We got to have an exponent. We got to have an exponent. And we got to have an exponent. So we're going to raise the exponent. Boom, boom. Here we go. Just keep drawing all of your rainbows. So the left side, I have 2. 1 times 4 is 4. 1 times 4, just follow your arrow. M, 1 times 4. And D, 3 times 4. So if you just follow your rainbows, it tells you where to go. Times M, 1 times 3 is 3. D, 1 times 3 is 3. Now, before I do any combining, I like to go ahead and get rid of this number here. So if I look at my calculator, 2 raised to the 4th power gives me 16, because remember, this is 2 times 2 times 2 times 2. So I have 16. Now I'm multiplying the same bases, so I'm going to add my exponents. So 4 plus 3 is 7. D, in the D, 12 plus 3 gives me 15. Final answer, because I don't know what the value of M or D is. Okay, I think you guys were doing kind of well with that one. Let's look at what about if we have something like a negative number, negative exponent. Remember, we talked about this today. I can never have a negative exponent. Remember, the simple rule we just said was put a 1 over it and change the negative to a positive. Okay, so same thing. Y to the negative 4th power is the same as 1 over y to the 4th power. Okay, all right. Let's put a couple of numbers with that, because the numbers are going to change it somewhat. What if I had something like 6 to the 3rd divided by 6 to the 5th? Okay, so we're going to add a little complexity to this one there. So now I'm dividing the same bases. And remember, we said numerator minus denominator. So 6 times 3 minus 5 would give me 6 to the negative 2nd power, because 3 minus 5 is negative 2. And I can't have that, so what I've got to do is change it to a fraction. But now I can finish this one out, because 6 squared means 6 times 6. So that gives me 1 over 36. Final answer, ladies and gentlemen, is 1 over 36. All right. So if you just keep working these negatives, anytime a negative pops up, just make sure you change it to a positive. Okay. Let's go back to one more division problem that's going to be a positive. I'll tell you what. Let's try this one first. Let's try this one. What if I have x to the negative first? We haven't tried one of these yet. I want to see what we can do with it. So what I want you to do is right now, remember, I'm going to just stop the video, and I want you to try to work this one out yourself. This is just a tease problem. This is a brain teaser problem. See if we can figure this out. Remember your rules. You're going to divide, so you got to subtract. So stop the video, and when you try it, come back and see what you have. Okay. All right. Welcome back. So let's try what we got. So remember, I'm dividing. Keep the base. We're going to subtract numerator minus denominator. So I'm going to subtract. But if you'll look, this is a negative 8. Okay. You guys learned a long time ago that, remember, if I'm subtracting a negative, that is the same as keep, flip, change, or keep, change, change. So I'm going to keep this one, I'm going to change this one, and I'm going to change this one. So now what I've actually got is x negative 1 plus 8, which gives me x to the 7th power. Okay, so just remember, keep, change, change, keep, flip, change. However you want to work that one. Okay. Let's try one more. What if I have m to the negative 3rd power over m to the negative 6th power? Same thing here, same base, negative 3 minus a negative 6. Well, I'm going to keep this guy, I'm going to change this guy, and I'm going to change the negative sign, right? So what I have is m to the negative 3 plus 6 gives me m to the 3rd power. All right. Let's reverse this and see what would happen. What would happen if I reverse this? What if I put m to the negative 6 on top and m to the negative 3 on the bottom? All right. So let's do it. So we have m, the power, I'm sorry, excuse me, the base is m, numerator minus denominator gives me keep, change, change. So I have m to the negative 3rd power, and then immediately my attention goes right here because I can't have that negative exponent, so I'm going to change it to 1 over m to the 3rd power. Okay, final answer right there, ladies and gentlemen. Good job. You guys are doing a great job with these in class today. All right, let's try a little combination. What if I give you something like x to the 2nd power, y to the 5th power? I know I'm jumping around as far as the steps, the types of problems I'm doing, but you've got to be able to do that on in the class. So we're going to see what we got. So I have x to the and then y to the fourth. All right. So we have a combination here. I have x and I have a y. So let's set it up. X to the second. I forgot to put my ghost, didn't I? Minus 1. And then y to the fifth power, minus 4 gives me x, y. Really it's x to the first, y to the first, but we don't have to write that 1 up here. If you do, it's fine, but understand you're going to see it that way. It's just x, y. Okay? Let's try something else. Let me see. I know we're working these kind of fast, but you have the ability to stop it and pause it. Okay, what if I add a coefficient to these things? What if I add something like this? What if I add 4 x to the fifth y divided by 16 x y to the fourth? Okay, first off, remember we talked about today in class, circle those coefficients. Now this says 4 over 16, so I need to reduce this. That's going to reduce to 1 over 4. Now let's tackle the exponents. So I have x to the fifth, I keep forgetting to put my ghost on it, minus 1, and then y to the first, minus 4. So if I keep going, so I have 1 over 4, x to the fourth, because 5 minus 1 is 4. But now right here, 1 minus 4 is going to give me a negative 3. Okay, so I'm looking here and I see this guy. So what I'm going to do is I'm going to drop right down here, rewrite my fraction, leave this guy up to the top, leave this exponent here, and let's bring this y to the negative third down here. And when we do, we change it to a positive answer. And remember, sometimes you're not going to see that written there. What you may see is something like this: 4y to the third power. These two answers are the same, but sometimes we just don't write the 1 because it's understood to be there. Okay? Good job with that one, ladies and gentlemen. Let's try something. Let's try one the other way. What if I give you 52x to the 12th divided by 13x to the 5th? Okay? So we're going to look here. I'm getting my coefficients. 52 divided by 13. If I remember that correctly, that should be 4. Let me see. 52 divided by 13 gives me 4. That's correct. Okay. So 4x 12 minus 5 gives me 4x to the 7th power. Okay. So it's just taking your time, working the steps out, and solving the problems out. All right, let's try this guy right here. What if I try? Let's do one more with these negatives. Let's see what we got. We have 2x to the fourth, y to the negative fourth, divided by 8, x to the seventh, y to the third. Well, I see my coefficients. Remember, this is a fraction. We want to reduce this. Okay, this says 2 divided by 8, not 8 divided by 2. So if I reduce that fraction, it's going to reduce to 1 over 4. All right, let's work the x's. I have x to the fourth minus x to the seventh, right? So 4 minus 7. Then I have y to the negative fourth minus 3. Okay, notice it's not minus a negative 3, it's just minus 3. So let's finish it out. So we have 1. 4 minus 7 is negative 3. Negative 4 minus 3. Okay, if you check with your calculator, negative 4 minus 3. Remember your integer rules say signs are the same. You're going to add the two numbers and you're going to keep the sign. So what we have here is y to the negative 7th over 4. All right. So I immediately look right here. I got a negative exponent here. I got a negative exponent here. So all I'm going to do is I'm going to leave the 1 on top, bring the 4 down, and x to the third, y to the 7th. Now this time I do have to leave the 1 because I have to have something in the numerator. Remember earlier we didn't use the 1 because we had some variables up here with it. But now this one is your final answer here. Okay? Great job, guys. You guys are doing an awesome job. All right. Y'all ready for one more of, let's try a negative exponent. Let's see what we got with that. What if I have something like 2x to the third power, y to the negative fourth power, raised up to the negative third power. Well, all right, so what I'm looking here, this is going to be a little bit of different problem. So what if I have an exponent here. So we're going to draw our draw our rainbows. So what I have is 2, 1 times negative 3, x 3 times negative 3, and y negative 4 times negative 3. All right, so we can work this out. So I have 2 to the negative third power, x to the negative ninth power, and y, now negative times negative is a positive. Okay, so if I'm looking at these problems, what I'm looking at now, I see a negative here and I see a negative here. So all I'm going to do immediately right now is I'm going to take those guys, put them in the bottom, and make them positive. Okay, get rid of that negative by putting them in the bottom, and since this is positive, I'm just going to leave it up here. So now we can solve. I can't solve here, I can't solve here, but I can do a little bit of work here because I know this actually means 2 times 2 times 2, right? So I have y to the 12th over 8x to the ninth power. Okay, that was a pretty tough one. Those negative exponents can be kind of tough on you. So just take your time, work them out really slow. All right, let's try one that you guys thought y'all really picked up on this one. I think y'all really liked doing these. What if I have something like, remember what we talked about this one, 7 to the 0 power? Remember, anything to the 0 power was 1. Okay, anything to the 0 power was 1. So don't forget that one. It kind of helps you out a little bit. So let's try one of these long ones out today. What if we have 2 to the third? Okay, that is a parentheses. A to the fourth, b to the third, all raised to the 0 power. Well, remember, we got to draw our rainbows. So what I have is 2, 3 times 0, a, 4 times 0, b, 3 times 0. So I have 2 to the 0, a to the 0, b to the 0. So 1 times 1 times 1 equals 1. So my final answer is 1. Good job with that one. That's a pretty tough problem, isn't it, guys? Okay. What do we try? Let's try one more before we wrap it up today. Let's try one of these. Let's try one more division problem. What if I have 24 x to the 6 divided by 12 x to the negative 8. I'm trying to do these because I want you guys to get in the habit of watching these negative signs. Okay, so here I have a coefficient. 24 divided by 12 is 2. Then I have a base of x, but now I have 6 minus, because I'm subtracting, right, a negative 8. So remember, keep, flip, change. Keep, change, change, however you want to call it. So what I have now is 2x 6 plus 8 gives me 2x to the 14th power. Okay, that's a lot of work for tonight. That's several problems. I hope you guys take the time to watch these videos and use them. And again, stop them sometimes, pause them. You can work on the problems and then you can restart them, and hopefully you can figure out the answers, and we can talk about them tomorrow in class. Okay? All right, you guys have a great evening. See you tomorrow.